Well, well, well. I hope this is the problem that piqued your interest. This is insert greatest common divisors in linked lists. Let's go ahead and get right into this problem. So you're given the head of a linked list head, in which each node contains an integer value. Okay, so this problem is already what I'm already thinking, and this is obviously a linked list problem. So I'm thinking about how do we process linked lists? What do linked lists usually look like as data structures, right? Is it doubly linked? Is it singly linked? Are we going to create a new linked list? Are we going to only return this linked list modified, right? Those are the kind of things that I'm almost always going to be thinking about when I see the word and read the word linked list in a problem. Okay. Now, between every pair of adjacent nodes, we want to insert a new node with a value equal to the greatest common divisor of them. Okay, so this is also one of those little math problems, and in particular, it's the greatest common divisor, right? And these problems can be kind of irritating because maybe you just aren't really well experienced in mathematics in that regard, right? Maybe you've been a software engineer for 20 years and you've never used greatest common divisors, but this problem requires that you understand what greatest common divisors are and how you can efficiently find them, right? And this gives someone who has an educational background a huge advantage because that person probably, learned this little obscure trick in school. Okay. Return the linked list after insertion. The greatest common divisor of two numbers is the largest positive integer that evenly divides both of them, right? So the greatest common divisor of 10 and 12 and 18 is 6, right? Because 12 divides 6 and 18 divides 6. So 6 is the greatest common divisor. Okay. Now, this problem can be frustrating, again, because you might understand linked lists, you might understand what this problem is asking, but you don't know how to find the greatest common divisor. So I'm going to approach this problem as if you don't know that information, just so that when you're in an interview, you can showcase to the interviewer that, I understand how to solve this problem. I know how to modulate it so that things I don't understand are abstracted. And then I can go online or I can go somewhere and I can figure out, this piece. But I'm not going to look at this problem. I'm not going to look at a problem when I'm working for your company and say, I don't know how to do one piece of this, so I'm not going to do any of it. So I'm going to solve this problem as if I don't know what greatest common divisors are, only that I know what linked lists are. And then I'll make it so that the information I don't know is modularized out, right? I separate that out, and at some later point, I'll determine the answer. If I'm rambling too much, I apologize. Okay, so let's look at this example here. All right, so we have the example 18. It's a singly linked list to 6 to 10 to 3. Now, notice that in this problem, it says that we want to return the linked list after insertion. So what that essentially means is we're not going to create a new linked list. We're going to have to modify this linked list in place, right? And when you're given a linked list data structure, right, you're going to be given the head, right, the address of the head if you're in C++, or you can just think of it abstractly as like some pointer to the head, however you want to look at it. But, you look at this head here, and this is the head of the linked list. And what you're going to have to do is in place somehow take this linked list, move this over, and enter in a new node, which is the greatest common divisor between 18 and 6, right? This value is the GCD of 18 and 6. And then for the next variable, you're going to do the identical thing. You're going to enter another value, which is the greatest common divisor of 6 and 10, which I think is 2. Damn, I'm good, man. And then finally, you're going to find the greatest common divisor between 10 and 3, and you're going to insert that here. So the greatest common divisor of 10 and 3, which is 3, I'm guessing. Or 3 doesn't divide 10. 10 doesn't divide 3. I'm an idiot. Is 1. Right, because they're co-prime or whatever. They're prime to each other. Even I'm starting to forget some of that, those mathematical concepts you learn in college. Right, so simple enough. The fact that we're doing this in place, we need to construct a manner in which we can do this kind of clearly, because you don't want to get this to get messy. Okay, now notice that we're taking the original nodes, these blue nodes, and we're finding the greatest common divisors. We never deal with the nodes in the center, right? So we process these two, we put something in the middle, and then we look at the next thing. Then we process these two, we put something in the middle, then we look at the next thing, right? So it makes sense that if we had this original system, right, like if we had some system, however it looks, I'm just going to draw a cloud, you know, and then we have two nodes we're looking at, let's say A and B. Oh, I'll make C as well. Okay, what I'm saying is when I insert something, I'm going to look at A and B, right? So I'm going to look at A and I'm going to look at B. So I'll call this pointer A and this pointer B, right? And what I'm going to do is what should happen at the next step? Well, I should insert something in between A and B, and then I should shift over, right? When I'm looking at trying to find what goes in between A and what goes in between B, imagine I've already processed everything to the left, so I'm just looking at these two things. Well, I should put something in between A and B and then move the things over. So what I mean by that is once I'm done with this first step, this is usually a pretty good approach to solving these problems, is trying to like look at a case to the next case, meaning look at a situation and then look at what needs to be the case at the next iteration and determine what needs to go where in order to make this work. So at the next iteration, what we should have is, we'll be done with A and B, and we'll then be looking at B and C, right? So that means that we're going to have a new node in here, and its value is going to be the greatest common divisor of, let's make that clear. So let's make this a big circle. So this, I don't want it to be too big. Okay, so this is the greatest common divisor of A and B, right? So that goes in between, but now we're going to do the same thing. So we need to move B over and we need to move A over, right? So from one iteration to the next, this is what should happen. We should have A and B. We should find its greatest common divisor, put it in between A and B, and then move A and B over, okay? So really what happens here is between one iteration, as I say, well, I'm going to have a new node, right? I'm going to call it, what should I call it? Because we're going to do it a little bit different. So let's just say G for our greatest common divisor equals the value, A's value, or we'll call it A because the pointer A, lowercase a. So the greatest common divisor between A and B, the value at A and the value at B, right? And then I'm going to create a new node, A. I'll call it G, which is a new linked list where its value is G, right? So basically, I'm finding what this G value is. I'm creating a new list node, and now A's next needs to be this. So I'd say A.next equals G. So that would create this link. So maybe I'll draw this out so you can kind of see functionally what I'm doing here. So I calculate G. So that's nothing here. So I do this. That creates this node. I say A.next equals G. So that's this link here. That's what this does. Right, so I'm trying to draw it. I'm saying this red thing creates this red thing. A.next equals G. That creates this link here. Right? Then I'll say G.next equals B. Right, because we're talking about this situation, right? Because this is one step and then what happens after. So if I say A.next equals this, this was initially B. So if this dot next equals B, so that is that's what creates this link here. And then I want to move things over. So now B, which was once my B, is now my A. So I'd say A equals B and B equals B dot next. Right? Okay, so that's what sets these two things up here. But okay, so let's just do this again really quickly. So we have a pointer A at A, and we have a pointer B at B, and these things are pointed to each other, and maybe they're C, and so on and so forth. Okay. When I say this, I find out what the greatest common value of is A of B. So then I say, okay, I'm going to calculate what G is, and that equals the greatest common divisor of A and B. I say G equals linked list of G, so I create a node Yeah, at this line, I create a node with the value G. I say a.next equals G, so I remove this link and I point it at G. Okay, I say G.next equals B, so I remove, no, I don't remove any link. I say G.next equals B, right? And then I say A equals B, so now A is no longer pointing here, A is pointing here. And then I say B equals B.next, B equals B.next. So now B points here. Is that right? So now when we go through this list, we're going to have ... A to G, right? I'm just following these links, to B to C. And then we'll have A pointing here and B pointing here now. So what I'm really trying to do here, right, is I'm just trying to specify that, you know what? I don't know much. Right? But the point I'm trying to specify here, right, is if you look at your problem, you look at in between iterations, you just got to find out where you plug things. Now notice that I've kind of compartmentalized this to just solving the linked list problem. I haven't even specified how I find what the greatest common divisor is, but I just know that that's what I need to find, and as long as I can convey the idea around setting up these pointers and making this new linked list, I'm good to go. And that should be sufficient to an interviewer, them knowing, okay, this person can solve the problem and then compartmentalize what they don't know. That way they can actually get as much work done as possible without saying, oh, I'm stuck and I'm lost, right? So let's go ahead and code this up. It's going to be slightly different the way I do it because there's a little bit of a, Pythonic trick you can do, I guess. But so what we'll do is we'll say, well, first, A is the head, right? It starts at the head, the first node. And B will be the second node, which is head.next. So maybe let's put that on one line just because we're being really cute today. Okay. And then we're going to do this until what? Until we don't have a right node, right? Because here we'll look at these two, then 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 these two. At the last iteration, you'll have B is nothing, and there's nothing to compare to. So we'll say while B, okay, I'm going to follow these steps, right? I'm going to create a new node, G, with its value of the greatest common divisor between A and B, right? So I'm going to say A.next equals a new list node where its value is the greatest common divisor between A's value and B's value. And then in place, right, the next I can set in the constructor, so the next will be B. And then I'll move over the pointers. I'll say A and B now equal A equals A.next and B equals, no, A equals B and B equals B.next, right? And that's here. A equals B, B equals B.next. So that'll move the pointers over. And I think I could probably do this on one line, but I'm not going to mess around with that game right now. And then at the end, we just return head, right? Because we're just modifying the linked list in place. So what we need to do is just find the greatest common divisor. Now, I'm not going to go over the mathematics here. There's probably a lot of good videos to figure out how greatest common divisors work and how you can find them efficiently. And I don't even really understand it anymore, to be honest with you. I've just memorized this greatest common divisor code because it comes up so often, right? So we're going to say def greatest common divisor of A and B. I've literally just memorized what this is, and I recommend you do too. If B equals 0, return A. Else, return greatest common divisor of B, A mod B. Memorize this code. It's going to make your life a whole lot easier. And I guess you could do this. Return A if B equals 0, else this. Just to get it a little bit cuter. You know what I mean? All right. We run that, and we cry because it's wrong. No. Runtime here is because, obviously we're going to look through the whole linked list once, right? So for time, okay, let's say n is the length of the linked list. right? So the length of the whole list, I guess. For time, we're going to have to look at each node in order to find the greatest common divisor between them. So that's going to take O of n time, right? Because we just linearly go through. We literally just look at each node and find what goes in between. Okay. For space, though, I'm a bit curious, right? Because you could say it's constant because I'm just creating these 2 pointers, right? Regardless of the size of the linked list, I just create 2 pointers and I just traverse through the linked list. But you know, this greatest common divisor uses stack space, right? It uses stack space to find whatever the, you know, greatest common divisor is. But since I don't even really intrinsically understand how it works, right? How far down can the stack really go, right? Or how many operations? And you know, it's definitely probably log of the max of nums, the max of head, meaning the max number in heads vows or something like that, right? But I'm guessing most people would just say this is O of 1. But technically, you know, depending on the number that you're finding the greatest common divisor for, there's going to be created stack space, and that is going to take up space. So say it's O of 1, but it might be something a little bit larger. If you know the answer to this, please let me know in the comments. Okay, peace out, guys.